Hey, they catch people.
Five ball.
Battery.
My laptop battery.
Sorry, please, everybody, can you mute your, can everybody please mute your audio, please? Oh, okay. So let me just. Thank you for everybody. Please everybody mute your audio.
Please, someone won't hear.
Can you all mute your audio, please? I can't. Okay, so let's start. So this example 4 is the last question. So please, everybody should follow along with this, because please, everybody, please, can you? Can every one of you all hear me? Sorry, can all of you hear me? I need feedback from the chat, please. I need feedback from the chat. Okay. Thank you. Thank you. I can see your responses. Okay, so the last question is on inverse Z transform. So if you remember in the Laplace case, I'm trying to mute.
A scandal between the two of them began in 2007.
Yes, certainly.
There's no, I don't know why.
And subsequently was induced in a coma for 5 days.
I can't see the function to block out mic, so I'll just continue because time is going. So let's just finish this class once and for all. So can you all see my screen? Can you all see my screen?
Yes,
Okay. All right, thank you. So the last question is the inverse Z transform. So just as you know, when we did Laplace transform in your 412, there's also inverse Laplace transform. So for the Z transform, you are converting a continuous time signal. For the Z transform, you are converting a discrete time signal into the Z domain. But for the inverse Z transform, you have the transform already in the Z domain. Then you want to convert it to the time domain. That's where the inverse Z transform comes in. So for the inverse Z transform, you're just trying to get the original signal in the time domain. You're trying to get it back from the Z domain. Then in the notes, if you read the notes, I said there are 3 methods you can use. Please keep quiet. Everybody, please keep quiet. I'm hearing a lot of noises from everybody, from some people. So please, everybody should try to keep. please. Okay, so I mentioned that there are three methods. Ma'am, mute everyone. I can't see the mute button from my side. I'm trying to locate the mute button, but I can't see it. So I'll just continue with the class. You guys should please behave yourself, please. So I said that there are three methods you can use to okay. All right, I've been able to mute everybody. So I said that there are three methods you can use to get the inverse Z transform. So you can use the power series method, power series expansion, the partial fractions expansion, or the inverse transform formula. So before I go to this, the conclusion from the last one is that you can either use y of k or y of kt. Both are the same thing. That's the conclusion. The reason why I said you guys should use y of k is because when I started the definition, it was x of k I used, not x of kt. That's the reason why. But I'm saying that you can use either of them. So that's the conclusion from the last meeting. So, okay, so there are three methods you can use actually to get the inverse Z transform. So this is the question, and you're asked to get the inverse Z transform. The first is the power series expansion. So the power series expansion is actually the simplest method you can use to get the inverse Z transform. So this is the fraction 0.3z divided by z minus 1, z minus 0.7. So for the power series expansion, what you simply do is to divide out 0.3z. This is the numerator. So the numerator is here. Then the denominator is here. So for this, you just expanded out. So if you multiply z minus 1 times z minus 0.7, you are going to get this. So for the power series expansion, you just divide this by this. So this is just simple algebra, is mathematics. So I would not bother explaining it. So it's just simply divide, find the remainder. Is kind of explanatory. You should have learned that in secondary school. So you do this, all the three methods. Let me tell you that all the three methods are very, very important. So you cannot just say that I will just learn this one method. I'm not going to learn the other methods. All the three methods are important. And in the quiz I'm going to be giving, you'll be asked to use all of the three methods because I want to test your understanding of all the three methods. So please listen carefully to all of the three methods. And if you have a question, please let me know on the chat. So this first method is the power series method. It's just simple algebra. Just divide this by this, then you get this. So I will not bother explaining. I'll not bother explaining this since this is just pure mathematics. So you get this. So if you look at this, the answer you got, it's already in the Z form because you have Z minus 1, Z minus 2, Z minus 3, Z minus 4, Z minus 5. And that's like, this is where K is equal to 1, K is equal to 2, K is equal to 3, K is equal to 4, and K is equal to 5. So, and okay, so this is the result. So this is the result of the of the division. Then when you observe the result, you will discover that if you look at in the notes, I gave you the Z transform table. So at this point, Z minus 1, the inverse Z transform is simply the impulse function, delta T minus capital letter T. So this is at Z minus 1. This is at Z minus 2. So this is just because you need the Z table. So from the Z table, you would observe that you would see it from the Z table. So I'll be uploading it's already in the notes I uploaded, but I'm going to upload a separate PDF file for the Z tables. So from the Z tables, you would observe, you're going to know that the inverse Laplace of Z minus 1 is an impulse function. This delta T minus T is an impulse function at T equals to capital letter T. Then this second one is also an impulse function, but at T is equal to 2T. And this is something as this, and this is something as this. Please, I need questions, observations on this. I need questions, observations, if you understand, if it's making sense, if it doesn't make sense. I want to know, I need feedback on this from the chat, please. Do you all understand? Okay, somebody says, makes sense so far. Okay, carry on. All right, thank you. Thank you very much. This method, somebody said, please, what method is this? This is the power series expansion. This is the power series expansion. All you just do is to divide the question. Just look at the question, then you're going to divide it, then you're going to get the result. So from this result, we just convert it directly into time domain. So that's the inverse Z transform. So that's the first method. So we move on to the second method. And the second method is using partial fraction expansion. So this partial fraction expansion is similar to Laplace transform. You know, in Laplace transform, when you want to convert to the time domain, you're going to first, okay, somebody said, what's of the remainder? You know, is an infinite series. So it depends on how far you can go. So for yeah, you could extend it to Z minus 5, minus 6, Z minus 7, Z minus 7. So you don't, we just have a fixed set of values to use. For instance, in the question, you might be asked to stop at Z minus 5 or Z minus 6. So we don't worry about the remainder. We don't worry about the remainder. You will just stop at where you feel comfortable to stop or where the question asks you to stop. So we don't worry. You don't worry yourself about the remainder. If you want to continue, you continue. And if you want to stop at any point, you're just going to stop at that point. So we are not so concerned. So somebody asked, how do we know when to stop? You're going to be told in the question that stop at Z minus 5 or stop at Z minus 6 or something. So you're going to be told when to stop. So that's for the power series method. For the partial fractions expansion, the partial fraction expansion is actually almost the same thing in the Laplace domain. So you just simply break down the question. This is the question. You will just simply break it down into partial fraction. But before breaking it down into partial fraction, this is very important. I'm making a very important point. Before breaking it down into partial fraction, you have to divide by z. This is very, very important. In the case of the Laplace domain, you just go straight to the point. You don't divide by z. But in the case of the z domain, before breaking it down into partial fraction, you have to divide the question by z. And I will tell you the reason why. I want everybody to understand what I've said. Please, on the chat, please, can you type on the chat what I said? What I said is that when you are using the partial fraction expansion to get the z transform, you first of all divide the question by z. That is very important. Please, I need feedback from the chat. Write divide by z before partial fraction expansion. Please, I need feedback. This is very important. You have to divide by z. You have to divide by z. You said, I don't really get that last part now. Okay, what I said is that, so okay, people are writing divide by z. What I'm saying is that in order to convert from the z domain into the time domain, you first of all have to divide the question by z. You have to divide by z. You know, in the Laplace domain, when you are given, if you're asked to convert into the Laplace, into the time domain from the Laplace domain, you just do it directly, no need of dividing. But in the case of the z transform, you first of all have to divide by z. This is very, very important. So you divide by z. So when you divide the question by z, you're going to get this. Then after dividing by z, when you get the partial fraction, then you multiply by z. So this is very important. First of all, divide by z, then break it down into partial fraction. Then after getting the partial fraction, multiply the result by z. So in this calculation, this is the partial fraction. If all of you can see the partial fraction, I skipped the calculation of how to convert into partial fraction. But obviously, when you are doing it for me in the quiz, you have to tell me how you got the partial fraction, because I don't want to waste my time typing how to get it. So that's why I did not do that. So, but when you are doing it for me, please tell me how you got the partial fraction. So after the class, if you want to verify that this is indeed the partial fraction, you can verify it on your own. So this is the partial fraction. Remember I said, first of all, you divide by z, you get the partial fraction. After getting the partial fraction, you multiply back by z. This is very important. And the reason why we are dividing by z and multiplying by z is because we want to get the partial fraction in this form. So let me go to the tables. Okay, so this is can you all see the z transform notes? I need feedback from the okay, this is the z transform. This is z transform table. So the reason why we divided by z and multiplied by z is because we want to, in partial fraction, we want to put it in this form, z minus 1. That's simply the reason why, because you know we already have we know that z minus 1 is a unit step. And the reason why I want to do that is we want to represent it in this form such that we'll be able to convert back into the time domain. Sorry, then for the second part, we have this form z minus exponential minus alpha t. Then the inverse z transform of this is this. So the reason, first of all, we have to divide by z. Then we have to multiply by z in order to get the full the inverse. Okay, somebody said your network is shaky. Okay. Okay, let me repeat what I said. So I said if you want to use partial fraction, first of all, you have to divide by z. Then after that, you multiply it by z. Then the reason why you have to do that is because you're going to get it in this form. So you know the inverse Laplace of this is a unit step, which is u of t. Then you know that the inverse Laplace of this is e minus at. So that's why you have to do it in this form. So let me go back. So let me go back to the question. So from the tables, the inverse Laplace of multiplied by z where? Somebody asked multiplied by z where? Because the reason why you're multiplying by z is because you divided by z before. So in order to get back the original question, you have to multiply it by z. That's why you are multiplying by z. Please, I need you all to understand this. This is very important. So that's the reason why you're multiplying by z. So when you, so after you multiply by z, you're going to get this. Then from the tables, I showed you the tables before. The inverse Laplace of this is 1, and a unit step is equal to 1 in the time domain. Then the inverse Laplace of z minus 0.7 is 0.7k. That's from the z transform tables. So can you all hear me? Can you hear me? I will try to repeat what I said. Can you hear me now? Okay, you can't hear me. Okay, maybe it's the network. Okay, I think it's the network. It's network connection. I think it's network connection. But let me just summarize. For the partial fraction expansion, you first of all divide by z. After dividing by z, you will get the partial fraction. Then you multiply by z back. Okay, you can now hear me now. Okay, thank you, Okoye Emeka. You can now hear me now. So you multiply by z back. It's because you divided by z previously. That's why you have to multiply by z back. Then from the z transform table, you would observe that z divided by z minus 1. The inverse z transform is 1. Then the inverse z transform of this is 0.7k. So all you just need to do is the variable that is here, you would, the variable that is here is raised to power k. So if you have it in this form, z divided by z, if it is z minus b, the inverse Laplace is b raised to power k. Please, can you show us the table? Okay. Want to see the table? Okay, I'm going to, the table in the notes is not the full table. So I'm going to upload a better table that you're going to see it properly. But this is the this is the Z table. So this is the Z table. You can see from the Z table that this is the Z transform. Then this is the time domain. So the Z transform of the unit step is Z minus 1. Then the unit step is just 1 because you have 1 here. Because you have 1 here. So the unit step is 1. So if the unit step, like for the previous question, we got Z minus K. So the inverse Z transform of Z minus K was delta T minus K. So that's why we got the delta here. So going back, to the question, the inverse Z transform of this is this variable that's on the right multiplied by K. So the inverse Z transform of Z minus 1 is 1 over K. And 1 over K is 1, so we just write 1 here. The inverse the inverse Z transform of this is the variable here raised to power K. So you have 0.7K. So did everybody understand how we got this? I need feedback from you guys. From here, how we got this from here is from the table. Okay, thank you. Thank you, Sam. So Sam says he understands. Any other person that understands? So it's from the table. Okay, so a lot of people said they understand. So thank you. I'll move on. So when you get this, then you just simply begin to change the value of K. So when K is equal to 0, instead of K here, you put 0, you get 0. When K is equal to 1, so you put 1 here. When K is equal to 2, 3, 4, 5, 6, 7, 8. So I stopped at 11. So these are the values you got. Then if you look at the values that was gotten in the second case, you would observe that it's still the same thing that you got in this first method. These were the variables for K is equal to 1, K is equal to 2, K is equal to 3, K is equal to 4. So it's basically the same thing you got in the first method, but you are using a different, somebody said, I don't understand how 1 was gotten. Isn't it 1 raised to the power of K? Yes. So VIE said 1 raised to the power of K is K. Like 1 raised to the power of since the it is 1 and you are raising it to the power of K. So any variable that you raise to the power, any variable that it has 1, like 1 raised to the power of 1 million is 1. 1 raised to the power of 1,000 is 1. So 1 raised to the power of K is 1. That is how we got 1. For K is equal to 0, is Y of 0 not supposed to be 1? No. For K is equal to 0. Thank you for that question. For K is equal to 0, you have 1 here, 1 minus 0.10, because K is equal to 0. Any number raised to the power of 0 is 1. 1 minus 1 is 0. The person that asked the question, do you understand now? Any number that you raise to the power of 0 is 1. 1 minus 1 is 0. The person that asked the question, do you understand now why K is equal to 0 is 0? The person that asked the question, do you understand now? Okay. Thank you. You said you understand now. Okay, I have less than 10 minutes. So I'll go to the last. So I'll go to the last formula. So the last method is the inverse transform formula. So this is the formula. This is the formula. Then you simply plug in the question into the formula. So you have to memorize the formula. So y of z is the question. So you simply put y of z. In the place of y of z, you're going to put in the formula. Then you put z k minus 1. Then the poles of the system. So the poles are at z is equal to 1 and z is equal to 0.7. So after you've done this, you're going to, you're going to break down the equation into two parts for each pole. So the numerator will be the same. But the denominator, you are going to separate it out into the two denominators. Then z multiplied by z k minus 1 is z of k. Then you find, you're going to put in the poles. So for the first expression, you will put in at z is equal to 1, where the denominator is z is the opposite denominator, that's z is equal to 0.7. Then for the second one, you are going to put in the value of z at the opposing pole. So it's kind of tricky at first when you look at it, but if you study it carefully, it's just it's easy. So basically, you will just use this formula. Then you're going to break down the question into the two denominators, one at z minus 1 and one at z minus 0.7, while maintaining the same numerator. Then you multiply this by zk minus 1, then you get z of k at both sides. Then you're going to substitute for z is equal to 1 for the first one, then for z is equal to 0.7 for the second one. So when you do the mathematics, you get 1.07k. So it might be difficult to understand at first, but when you study it, you're going to arrive at the same equation we got for the previous case. So these are the examples. So if there are any questions now, I have less than 10 minutes. Oh, sorry, I have 5 minutes now before it's going to be over. So if there are any questions, please let me know so that I will just round up. Yes, somebody said this method is the fastest. Yes. Someone said, Ma, for the previous step, do we have to do up to k is equal to 11? Actually, you'll be told when to stop. You'll be told when to stop. So in the question, you're going to be told when to stop. Either to stop at k is equal to 5 or k is equal to 11. You'll be told when to stop. So I just decided to stop there. Okay, so thank you all. Somebody said no questions. So I hope that you guys have been able to, you understand Z transforms better based on this class. So I want you all to watch out for the quiz. I'm going to be setting up the quiz today. So try to watch out for the quiz. Then based on what we've done so far, you would submit it. How soon can we get the recording? You're getting the recording today. So I'll make sure I upload it on Moodle today. So latest tomorrow morning, you will get the question. So how do we use the inverse formula method if there are three poles? So that's a very good question. I wish I could do, can the method 3 be used for triples? Yes. I'm going to, thank you for the question. So I'm going to upload another solution using 3 poles. How is the final answer 1 minus 0? No, is 1 minus 0.7 raised to the power of 0. So Ugo, Ikechi, 1 minus 0.7 raised to the power of 0. Any number raised to the power of 0 is 1. So it becomes 1 minus 1. So is 1 minus 1. 1 minus 1 is equal to 0. Because 0.7 raised to power of 0 is 1. So it's actually 1 minus 1, you get 0. So Ugo, Ikechi, do you understand my explanation? You don't understand? Okay. It's just simple arithmetic. 0.0 raised to the power of 0 is 1. Then 1 minus 1. I'm talking about the last answer. Okay. Yes, 0.7 minus 1 is 0.3. 0.3 divided by 0.3 is 1. So you get 0.7k. 1 minus 0.7 is 0.3. 0.3 divided by 0.3 is still 1 raised to power k. And 1 raised to power k is 1. So it's still the answer. It's just, it's simply mathematics we are doing here. So I'm going to, yes, there'll be enough time for the quiz. There'll be enough time. Okay, Ikechi says he understands now. Thank you very much. So I'm going to thank you all for the cooperation. For the last method, do we need to input values for k like we did? Yes, you need to. Yes, you need to, or you'll be told in the question. You're going to be told that for k, do for k till k is equal to 11. So, is there a range of values for k? What of if k is negative? That's a very good question, Emmanuel. K cannot be negative. And the reason why k cannot be negative is because look at your definition for Z transform. K starts from 0. This is the definition. So k can never be negative. K can never be negative because in the definition of Z transform, k starts from 0. So you have less than 1 minute now. So I'm going to thank you all for the cooperation. So I'm going to be ending the meeting now.